Thank you for joining me once again. My name is Ngozi Adeleye, founder CrunchEconometrix. In this video, I will be showing you how you can generate conditional margin plots whenever you estimate moderation models, or what we refer to as interaction models. On the screen, I have two definitions for conditional margin plots. The first says it is a plot that graphically shows the effects of a regressor on a dependent variable conditioned on the behavior of another regressor. The second definition says it is a graph that illustrates the marginal effects of one regressor on the dependent variable conditional on specific values or ranges of another regressor. I have several videos on moderation models. I will encourage you to watch them all for more informed understanding. Before I go into today's video, I want to introduce again my videos on the Teachable platform, that is PEBA on Teachable. PEBA means Practical Econometrics for researchers, beginners, and advanced level users. If you are yet to sign up or enroll into PEBA, I'm here to tell you that you are missing out. You are missing a lot. There are two ways by which you can access PEBA. You can either access by signing up, and you'll be able to watch about 10 to 15 free videos I've uploaded. These are quality videos. But if you want to take more advantage of PEBA, it is better for you to enroll with $100. It is a non-recurring payment. It is a one-time enrollment fee. Whenever you enroll, you have access to watch over 90 premium videos curated using Stata and eViews, and these videos are suitable for all PhD students and for researchers across all levels, whether you are a beginner researcher or you are an experienced researcher. For all enrollees, you will have free access to any data set I used, Stata do files, and any articles that will support the estimation technique. All these data sets are available in Excel so that eViews users can import them into eViews. In the case where there are no data sets, then I will encourage you to use your own data set. Everybody will have access to prompt response whenever you post your queries on your dashboard, whether you signed up only or you enrolled. I'm going to drop the link for PEBA in the video description, so make sure you enroll with $100, and I'll see you in class. Now, I'm using the Titanic 3 data set, and you can see the objective on the screen. It is to show if the effects of the sex of the passenger on fare changes with the age of the passenger. Again, I am using the Titanic 3 data set, so let me just show you how the data set looks like. It's a very rich data set, and I'm going to be making this available. If you want the full data set, just go to Kaggle, Kaggle, and you can download the data set free of charge. So what I have here is the abridged version. So I'll be making this available for anyone that wants to replicate what I'll be doing in this video. The do file will also be made available, so you don't have to worry. Free of charge for everyone, so that you can replicate the analysis. I will also put the link on where you can get access to this do file. It's free of charge. You don't have to pay for this. So again, back to the objective. We want to see the effect of fare, whether it changes with the age of the passenger. And this is the model that we are going to estimate. Fare, the dependent variable, is a ticket fare. Female is a binary dependent variable. 1 if the person is female, 0 if the person is male. Age is a continuous independent variable which relates to the age of the individual, and we have the interaction term, female, and age. The subscript I is just to tell you that I am using a cross-sectional data. So having defined the variables, let's move to Stata and estimate this model. So here in Stata, we need to regress the model, but before we do, let me explain this factor notation that I have here. I am using Stata factor notation, where the interaction of female, the binary variable, is with age continuous variable. So the double hashtag here just tells you I am interacting two regressors, okay? I am interacting two regressors, and the I dot is because this is a binary variable, and the C dot shows this is a continuous variable. So this is a shortcut for me. I use this often whenever I'm doing moderation model. So let's execute and let's see what we have. So here's the results of our estimated model. So I'll be moving on to PowerPoint to discuss these results before I show you how you can generate the margin plots. This results interpretation will help you in case you are writing a manuscript or your dissertation, you are using interaction terms. I'm sure you are going to find most of this interpretation relatable. Let's start with the constant. What does it relate to? The constant is 14.76 on approximation. It is simply the baseline fare for a male passenger who is an infant. So such an infant will pay 14.76. Okay, this may not sound too intuitive, but that is the value, and that is what the constant represents. Next, I move on to age. The age coefficient is also approximately 0.45, and what does that tell us? It simply tells us that for male passengers, each extra year of age is associated with an increase of $0.45 in fare, and we can see that the effect is significant at the 1% level. So this age here relates to the age of the passengers that are male. Okay, and don't forget that the base dummy is male. Female equals 1 is female, and female equals 0 is male. So male is a reference dummy. Let's look at the female coefficient, 1.04 approximately. It tells us that regardless of your age, being female, you are expected to pay 1.04 more in fares compared to males, as simple as that. But we can see that the effect is not significant at all. P-value is very high, 0.894. Or you can also define it as additionally, female passengers pay extra 1.040 more than male of the same age. Okay, so I'm giving this interpretation just in case you run your own estimation model, you find it significant, then you can also say this effect is significant. Okay, but in this case, the effect is not significant. So we move on to the most important coefficient in the model, which is the interaction coefficient beta 3. What does that tell us? We have 0.748, which is approximately 0.75. How will you interpret this? You can simply say for female passengers, each extra year of age adds 0.75 on top of the male age effect. And we can say that the effect is significant at the 1% level. So the total age effect for female, if you sum it up, is going to be the male age effect and that of the female, giving us 1.198 or approximately 1.2. So how are you going to conclude this? You can simply say that each additional year of age increases fare by 1.2 for female and 0.45 for males. As simple as that. So all the coefficients have been beautifully interpreted. If you have a contrary interpretation, I would love to hear your views. Please put them in the comment section. So next I move on to the margin plot generation, visualization and interpretation. So this is what I have on PowerPoint. Let's go to Stata and I'm going to show you the code I used to generate this. So for you to generate the margin plots, you have to go through, let's say, 3 steps. First of all, you need to get the summary statistics for age, create the margins, then plot the margin. So let's run this and get the summary statistics for age. So here we can see the summary statistics for age. Okay, so the lowest age of the passenger is an infant on the ship, 0.17, and the oldest passenger is 80 years. So this is the age boundary from 0 to 80. We need this information to help us to plot the margins. So in plotting the margins, you can see I've already plugged this in here. Lowest age approximately 1 year old. You can even put 0. It's also correct. And the highest 80. And in between, I'm putting a 5-year interval. Okay. So this is the margin. And you can see I female because I want to draw the margins on the binary variable. So let me run this code. So here we have the results from the margins. So you can see at different intervals of age, you can see the predicted value of the fare. Okay, conditional on the sex, either male or female. Okay, so this is what Stata will give you, and you can see the table that Stata also generates for the margins. Then next, let us plot for visualization all the statistics that we have seen. All you have to do, run this code, the Marginsplot code. Don't forget, you are going to have access to this do file, so you can replicate it and see how far you can go. So let's execute, and here we are. So this is the effect of sex on fare by age, and we can see female, that is red, and we can see the male in blue. So let's move over to PowerPoint. So there are several insights we can get from this visualization, several insights, okay? My interpretation may be different from yours. Again, I would love to hear your opinion. First insight, I observed that the gap between the red and the blue lines widens with age. So the gap between male and female increases with age. So what does that tell us? It indicates that the effect of sex on fare increases as the age increases. So we are having a positive interaction effect between sex and age. And this is a great example of showing you how interaction terms can reveal extra insights into your model. So I will always encourage you, whenever you are in a regression, don't just run a straight line or a linear model. Try to include interactions to bring out more nuanced relationships embedded within your data. I was able to also curate two statements from this plot. The first one is that I said women of the same age as men pay higher fares. Why did I say so? Because I'm able to see that even when they are of the same age, women are paying more. Okay? The female coefficient is positive, meaning that female pay more than male even when they are of the same age. Look at somebody is age 46. Being male pays lower than a female that is 46, and that same goes to all the age categories or different age levels. Okay, and we can say again for emphasis, the interaction coefficient between sex and age is positive, meaning that the difference in the fare between male and female will always increase with age. That is one statement. Let's look at the second statement I got from these plots. I said the older you are, the higher the fare. Which makes sense, because I'm able to see that as you are growing older, your fare is increasing. The age coefficient is positive, indicating that age increases with fare. And we can see that this effect is stronger for female. It appears to be that as you are getting older as a female, your fare is more for whatever reason, because that is what we are seeing in this graph. So the older you are, the higher the fare. In summary, I'm concluding that the base fare increases with age. I'm concluding that females pay more than males at any given age, or even when they are of the same age. And I'm also concluding that the gap widens as age increases due to the interaction effect. If you have more conclusions from what you've seen, again, I would love to read your comments. Now, have you used interaction terms in your models? What did you find? How can you interpret your margins based on what you've listened to today? I'd love to read your comments regarding this. I have so many publications where I used conditional margin plots from my interaction models. These are some of those papers. If you are interested, reach out to me on ResearchGate and you can download these papers free of charge. I really appreciate you all for listening. Thank you for your time. I'm not taking it for granted. I would love to read your comments. Please help me to help me to share this video so that your students, your colleagues, and those within your academic network can come in contact with these videos and they can enrich their understanding. Thank you so much. Please don't go away. I'll be right back with my next video.